Thanks, Alan, and thanks everybody for being here. So I think in this presentation, you will get your hands dirty. You will go into the CBRAIN, and we try to do something. I have no disclosure to say. You have seen this before. I just want to say that all this effort that we have been doing for many years start from a collaboration very long time ago between all our institutions, and that CBRAIN and LORIS are the core of the platform that we have developed for open science, that we are promoting through the CBRAIN, through the MNI, the EEG Net, and the Global Brain Consortium. So our purpose is that we will be collecting in this platform freely all the tools that we have been developing during the years for the EEG analysis. We have talked about two types, so Pedro and Maria have talked about two types of quantitative, or two toolboxes of quantitative EEG analysis. The old one that we call qEEGT, that T from tomographic, that is the old one, more traditional one that we developed, was the first that Pedro explained, developed in the 90s based on the Cuban normative population. And then we have the harmonized qEEG, that is a multinational effort that we made in 2022 based within the Global Brain Consortium, and bringing together scientists of many countries, and I will explain the new things that we add to the quantitative EEG analysis. This toolbox was incorporated to CBRAIN. Maybe in 2018, we incorporated this toolbox to CBRAIN as the first EEG facility in CBRAIN. To use the toolbox in the CBRAIN, what you need to do is first log in the CBRAIN portal and ask for a user. In this case, Brian has created many users to speed up this step, but this is something that you just go to the portal, ask for your using, and you get your account, and then you can enter the CBRAIN. I think that all the people that is going to participate already has a user and a password that Brian provided before. So you just log in CBRAIN, and then the first thing that you need to do is to create a project where you are going to work. So you create a project. In this case, I call this qEEGT demo, and then just push create, and then the project appears. How many people are going to do it? Is anyone doing that?
We haven't got our emails.
You,
Can you check your junk folder?
Yeah.
Just in case.
is there anyone doing? You already created the project? But now you are okay? Okay.
Is it shared from your email?
No, it's from
You need a user. You don't have the user. Maybe you,
It should have sent. So you should put your account. Look, it should have resent you the email.
okay, thank you. Or maybe we can tell her. We can tell her.
We'll follow this. We'll help you out after, so that you just didn't resolve it. I'll do that.
Okay. So only one person is following me. Okay. ¿Qué pasó ahí? No, you go. Go to the beginning. Okay, I just try to. No, but I will ask him to. I just try to make this very didactic, step by step, so you have the presentation, and anytime you want to do, you can do it later also. Okay, then you create your project, and the project appears there. And then the next step is that you need to process your data. But to process your data, the first thing you need to do is to prepare the data to be incorporated to CBRAIN, to be uploaded to CBRAIN, no? The qEEGT has 3 formats that accepts as input. One is the EEG BIDS format. Another one is the PLG format, that is the data structure, the EEG structure created by the Cuban systems, EEG systems. And the other one is a generic ASCII file that is prepared in this way, and that you can use. So you can prepare your data like this, and it will you will use them as input for your processing. The first thing that you need to know is that you send the qEEG, you send clean signal, not the whole spectra. You need clean signal, so before sending to the qEEG, you need to select the analysis windows. This is done by an expert that knows, is able to select artifact-free windows and quasi-stationary windows, epochs of EEG. And normally, we use epochs of 2.56 seconds. For the quantitative EEG analysis, it's not necessary, but we prefer this size because this is the size that we use when we created the norms. So it's better to use this one. But in general, you don't need to do this exactly. Depending on the size of your epoch, the frequency analysis will change because you will not have the same frequency resolution as we have when we created the norms.
For those accounts, the email only gets sent when you request a reset of the password. So you need to go to the portal, and then you say request password reset. So there's no a priori email. So I just want to clarify that point, sorry. But we'll show this in.
So we've just done it. But we did sign up before with the same email.
Okay, next. Okay. So then, outside CBRAIN, you prepare your data. And the easiest way to do it is that you create one directory for each subject. It's the easiest way because then when you upload this to CBRAIN, it will be easier to run all the subjects. You can get all at the same time. So then you create this, prepare like this, and you use an FTP software to upload to CBRAIN. It's the easiest way because you don't need to do it one by one. So you just use FTP facility, and it will transfer all the data to CBRAIN. When you have this, what you are going to do? You go to resources and to data providers. You open resources and data providers. And then you go to user or site storage and scroll down up to the top, the bottom. And at the bottom, you will find this. FTP1 is FTP2. And you will get the information of these two servers. You can select any of them, and then and then you click, and since you already uploaded the data by using the FTP client, you will see all your data here to be ready to be registered in your project. Okay? Then you just need to click. Si esto me sirve para matar. Here. This is back. This is to light. This is net, and this is light. Light? Okay. Okay. Okay, then you select your project, the project that you created, and then you type register the files, and then you press here, register the files, and all the files you have in the FTP goes to your project. Just in one step. And you already have your data there. Then you go to here to CBRAIN, and you have your data here in qEEGT demo. Then you press here to start the processing. Can you go back? No, go back. Then you will see here all the subjects that you uploaded. And then you mark them, because these are the files that you are going to process. And then you press launch. After I finish this explanation, we will do it with Brian, because he already has some data prepared. So for now, just follow me, and then we do it with Brian. Okay? Then you go and you say launch. And, okay. When you press launch, you get all the toolboxes that are defined in CBRAIN. And then we are going to select the qEEG, the qEEGT. We double-click here to put the plugin active. We select here the server. Depending on the server, it will depend. You will have to know by experience which server is always more free or more busy. So in this case, I use Beluga 1.00, and then I go to prepare EEG. So I just tell the CBRAIN in which server I am going to run my task. And here appears this window where I have all the options I have for calculating the qEEG. The first thing is that I select the directory where I'm going to store my output, my results. And then, in this case, I am using files that are PLG format, so were recorded with our equipment. In the case that you use your text file, for example, you put here text. Or if you use BIDS file, you put here the name or the wildcard of your cases. Mm-hmm. And then we select, normally stay A. You can select stay B, that is eyes open. We have norms for eyes open too. And as I was telling you, we used 2.56 seconds for the analysis window. You need to guarantee that your files has 2.56 seconds for the analysis. And these are all the chances that we have here. This is the frequency resolution from 0.39 with a step of 0.39 to 19 hertz is the frequency range that we normally analyze. You can change that according to your interest. And we also define which are the bands, the frequency bands for defining the broadband model. The broadband model is the model that is delta, theta, alpha, and beta. Normally, you know that these broadband model are defined from 1.5 to 3.5, from 3.5 to 7.5 hertz. 7.5 to 12.5 is alpha, and 12.5 to 20 is beta. But you can if you use another definition, you can change it here. Then here is if I am going to calculate the solution at the sources. If I want to stay only at the scalp, or I want to have also the solution at the sources. Here is a power, geometrical power. If I want to apply the geometrical power. The geometrical power is a kind of Bosch effect that we defined a long time ago. The idea is similar to the Bosch effect that Pedro described in his talk, but this is more related to the subject. This is more correcting different baselines that sometimes the EEG of the people comes in different baselines, and it's a kind of baseline correction to avoid getting statistical differences, not because the activity of the person was higher than the other, but just because they were this here and this here. So they were not referred to the same level. Then, if I want to calculate the broadband, the narrow band, if I want to get the spectra, the C values, so the normative values for the broadband spectral, for the narrow band spectral, and for the spectra also. So, and here we have for the sources, calculate norms at the sources. If we want to get the correlation matrix, the coherence matrix, the phase differences matrix, frequency domain correlations, and if we want to work with, so you know the Lick field is not a number. The Lick field is a field. It's a 3D-dimensional field that has components in the 3 axes, x, y, z. Normally, we project them to somewhere using some method, but if you want to work with them with the 3 fields, you can do it also. Then you decide whether you want to use or you don't want to use. And finally, you set the output directory where you want to save your results. So there are many options here that you can select depending on what you want to do. Mm-hmm. And then you go start qEEG when you have everything set. And then we go, we can see the task. We go to this tab and we see the task, and we see all the tasks that were calculated, no, at the server. And we have that almost all of them completed, and we have one that failed on the cluster, and this can be due to lacking of resources or something that happened in the cluster, and then you can retry this one. You can send this again for calculation. Let's stop here, and then let's see a practical demonstration by Brian here. And I will be explaining while he is doing that. I will be explaining what he did. So he opened the CBRAIN portal. He went to the CBRAIN portal. He put his user, the password, and when he put his user and password, he gets this window, okay, where he already have this project defined, OHBM 002 EEG project, okay? Now, I told you that he already prepared the data. If you are already inside the CBRAIN, you can go to this tab, Project, Share with Me. You can go here, and you will see all of these projects. These are the projects where he uploaded the data. And look at, this is a very nice way of organizing the data, because if you are working in many different projects, you have your data organized by different projects. So when you are going to work with this, you don't need to have everything on the screen. Here I have this. Here I have this. I put here some subjects of the Barbados study that Marie explained. I didn't put the whole data set because it's too much. I just selected 5, 6 subjects. I put some control here, and I put some children with malnutrition in the other group. So these are some of the children. So this is control data, and these are children with malnutrition, and then we can send this to our project for processing, okay? So now Brian selects, and you have all this data already in your project. And then you just need a click, and you can go and launch the task. See that the step that takes more time is preparing the data. No? You need to prepare your data. You go to, you use an FTP client. You upload the data to one of the FTP of CBRAIN, and after you do that, everything is very simple. You just come here and you select the files, launch the task, and then you select the qEEG, select the server where you are going to run. In this case, he's going to select this one, and then you can launch the task.
See, there's four people connected in.
Mm-hmm.
We need to make a new project that is
Okay. Anyone has any problem, or you are there?
So once you're logging in, you'll click on the project shared with me, and then you'll see these data files as Bosch was indicating it and prepare over.
Mm-hmm. Okay, yes.
If we're excluding.
Okay. Okay, then now you go to launch, and using this, you select here the server. We are using this, looks to be fast now. Okay. And then launch. Then you need to select your data provider, not data provider, but where you are going to save the results. And we usually select main store. Mm-hmm.
They should choose their personal project.
Then you should use here your user project.
The one that corresponds to your account.
Mm-hmm. Okay, here we put we use the wildcard aster to indicate that we want to process all the files. Mm-hmm. So you don't need to go subject by subject, you put the generic name. And all these parameters are set up by default. If you need to change some of them, you can change it. But normally, this is what we do. And then everything is already selected. And then here you can select the name of the file where you are going to save the results. And then you can start the qEEG. So start the qEEG. It launches a task, or one task for each subject. Mm-hmm. And if you go to the tabs of your project, you will see all of them running on the, So they are already on CPU because this server is fast, so it replies fast. So now we need to wait for them to complete. In this case, the qEEG is very fast. So already completed. Now we can go to either here or to files. So you will show here. Okay. Now we can see some of the files. We can see some of the results. We have implemented a very brief, very simple viewer here for just having a first look at the data, at the results. What you need to do is that you can see all the files that were created by the process, and you, can you go back and to tell, then you need to come here. You need to come here and click on edit. This is for visualization. You need to click on edit and then okay. And then here, you change to mod file, mod collection, to mod collection, and you click update. What we are doing here is indicating the CBRAIN, the type of file that they have, and when the CBRAIN knows the type of file, he calls immediately this the viewer, where we can see here. In this case, we are looking at narrow band, so this is frequency by frequency, and this is raw data. This is raw data. If you click here, you can change. You can see, for example, the values, the normative values. Nothing. Go. Go to this one. But I think this is already normative data. Yeah, it's showing this. Because this is between -4 and 4, so this is a statistical scale. You can move the cursor and put and you can inspect all the frequencies. You can see, and it will be showing you the results. And then maybe you can click here or here. No. What is broadband spectral model? Okay, if you click on broadband, then you can see the result by frequency bands. This is delta, this is theta, this is alpha, beta, and the total. And this is the normative value, so the three values, in absolute value, in relative power, and in median frequency. This is the most well-known quantitative EEG analysis, because people used to summarize the results by frequency bands. People don't use to look at each frequency. They always like to summarize and see by frequency bands. So this is one thing that we can do. Unfortunately, we are not looking at the solutions at the sources. I don't know why it is not showing. Can you go to the presentation? To my presentation. So this is how it should appear. Normally, you will have this. I don't know why it's not showing this now, but this is at the solutions at the sources. So you can see at the same time the spectra, the topographical map at the specific frequency, and the tomographical map at the cortex. And then you can see where are the solution is bigger, and then you can change and you can see the t-values, and you can know where are the more pathological values in this subject. Sorry? Source localization, yes, source localization.
So are you using a standard MRI?
Yes, yes, exactly. So this is what we should be looking at in the other screen, but it's not showing so we need to check what happened with this. But it will be solved because it was working. It will be solved soon. I don't know why. So this is for the qEEGT. Let's see now the harmonized qEEG, which is the main difference between the qEEGT and the harmonized qEEG. For the moment, we don't have solution for the harmonized qEEG. The harmonized qEEG introduces many new features. One is the batch correction that allows comparing data coming from different devices. The other one is calculating norms for the full cross-spectral matrix. Here you see that we only see the spectra. We don't have anything, we don't know anything about the cross-spectra. But with the new methodology, we can normalize and we can inspect pathological values in the cross-spectra. This is much more important because, you know, most of the pathologies in the brain are related to connectivity between different areas of the brain. It's not just that the activity, the amplitude of the activity is decreased or increased in one region. It is because different regions are not communicating. That's why people have studied the coherence so much during many years. And we are going to introduce this in the harmonized qEEG, but for the moment, the harmonized qEEG is only at the scalp. Even with the harmonized qEEG at the scalp, as you saw in Pedro's and Maria's presentation, using the full cross-spectral matrix for the qEEG analysis increased dramatically the classification power of the EEG. So the results the classification equation that we can obtain with the harmonized qEEG are able to separate much better different groups than before using only the log spectrum. The good thing is that our previous methodology is very compatible, very consistent with the new one. So we were not doing well, we were doing well, but now we can do it better. So can we go to the harmonized qEEG? Let me first show the presentation. Can we go to the presentation? Okay, this is the broadband. These are coherences. So here, for example, in this case, you put which is the coherence map regarding each electrode. So this is FP1, the coherence of FP1 against all electrodes, the coherence FP2. Then you change the electrode and you obtain the correlation map of this electrode with the rest of them. And then the harmonized toolbox. We are going to show with Brian now. This is only to show the new features in this. Here, since this is a new one, we have set many more different formats. So we have said EEG BIDS, EDF, BDF, PLG, EEG lab, text format, the same text format as before. And then we can call the EEG. Since the EEG BIDS structure is already defined, we also define the qEEG derivatives for the integration in EEG BIDS structure. This is stored in a HDF file format with all the parameters inside in a very compact way. Maybe I will show you later after we have some results. Okay? Then, can you go? Now, Brian is going to show you what we can. Go back for them to know which data set they have to select. Okay, from here you can go to projects, then you go to project share with me, and you can select this data. I have a video showing how to prepare the data. We will see later after we do this. So let's start from this here. And for this, we have the example data. That is a file that we prepared. We will see how prepared in the video. And we can have also an additional table. In this case, we use MATLAB, but this can be this can be an Excel table or CSV file. And this table, we will see later, is a table that contains additional information of the subject, because many times the EEG comes without the age of the subject, for example, or without the sex, or without other data. And if we need this information for the analysis, we have this option that for each subject, they put all the additional information we need. Okay, then in this file, we have these two. In this project, we have these two files. Brian is going to mark them, and he will find now the harmonized qEEG. And then he will again converter, the server converter, launch the harmonized qEEG, and then you already have these two files. You need to mark the two files before launch the task. Okay? You need to mark the two files, and then you launch the task. Okay. Then you go launch, and then you find the harmonized qEEG. Select this. Okay, and then you. Can you go to files? Oh, yeah, in files. Why is you? Can you maybe, can you change the project, maybe? Can you change to the presentation? While Brian is fixing the problem, so these are all the steps you need to run. This is a 2 minutes video. I had put some captions here, but I'm not presenting. So this is the table I was mentioning. You create this table. You can create this table with Excel or anything. Then What you need to do is you have one directory, you have all the files, and then you zip all the subjects in just one file. You put all your subjects in one zip file, and you upload it. And then you upload also the additional table. Then you launch, select the harmonized qEEG, and then you set all the parameters. So this is Beluga, and then, so here in this you have to put the file that contains the subjects. And here you need to put the files that contain the metadata. And then you mark all the options. Here you select which batch correction you want. If you have one of the ones that we have here, you select that. But if you don't know from which device your subject comes, you don't use, or you use one that you suppose is near to the ones we have. And then you send the task to room. This is Q now in the. So the batch correction, we have 14 different equipment they are put. They are very common, so it will be okay for many people. But if you have your own device that is not included in our software, and you can record a sample of 30 or 40 normal subjects, you can send those, and we can calculate the batch correction factor for your data, and we can incorporate. Neuroscan? I think there is, yes, I think there is Neuroscan there, yes. Neuroscan is one of them. We have many different that are used in China. We have the one that is old, that is the DIDAS, that is the one used in Barbados and New York. We have Neuroscan, I think we have Brain Vision. I think Nicolette. There are 14 different devices. So you see, this is just showing how is. Are you ready, Ibrahim? Just showing all the subject. This is a little takes a little more time than qEEGT. qEEGT is very fast. And okay, finish with all subjects. It's giving you all the information. Maybe you can. Okay. Let me just, I will just advance here. This is. At the end. More. Okay, you're ready. Finish calculating. So now it's showing the files that were calculated is the H5 that I was telling you. And in the next slide, we will see how to view it. Okay, then we have a visualizer that is also a very simple visualizer. This visualizer was we had in Azure, in MATLAB server, but it's not right now online. But if you are going to use, we can give you the MATLAB application and you can use locally, while we put this again in internet. Because right now it is not in internet, but we can give you the application and you can use locally. So it is loading the data, so this is the result. And you can see here, you drop the result here. And then it shows you the t-scores for the spectra and for the cross spectra. And you can see, and for example, this is the harmonized of cross spectra. And then now you see that besides the map, you have lines, not arrows, but lines joining them. So these are the correlations that are significant in this case. And this is very useful for the study of pathologies, for example. If you want to study a group of dyslexia, you can analyze how is the correlation, and then you can compare with with a control group or something. Now, not everything is solved inside CBRAIN. Not everything. So we have these tools, but if you want to do the statistical analysis, you have to download all the results and you do the statistical analysis outside. In the future, we plan to put all the, can you go back to my presentation? We plan to put all the toolboxes we have. For example, the biomarkers toolbox, is my presentation? The biomarker toolbox that Maria presented in her speech that we use for the NeuroEpoch project is already in the CBRAIN. And this biomarker toolbox is very interesting because it's very robust. So it is created using a very robust statistical methodology that using elastic net technique to get sparse solutions, so we don't get coefficients for biomarker coefficient for all variables in each state, and we do a random procedure to select the biomarker with different subsamples, and at the end, so we take which are the variables with higher power for classification, and then we do a stable ROC-based procedure, also random, to avoid giving very high ROC estimates. The majority of the studies that we do are very optimistic. This, on the contrary, is very conservative. So the estimation that comes out from here is very conservative and should be reflecting the best we can the real statistical power of your sample. This is very important when we work with small samples, because normally people tend to be too optimistic. They use very small sample, they give very high ROC values, and when you change slightly the sample, then it changes a lot also. We try to, that our estimator is more or less robust, for the more robust that we can for this sample that you have. I think we can stop here. because so this is the biomarker toolbox in CBRAIN, producing this area on the curve, and this is a result of the analysis of a group of differentiation of 3 dyslexic groups with a control group. Children with different type of dyslexia, and you can see the percent of classification is very high in this case. So there is a high power of the EEG to classify the different type of dyslexia. There are other toolboxes in the CBRAIN, but so this is for now. If you have any question or...
Can I ask about your normative database? Sorry, I'm just catching up with some of the research. Is the Multinational Database?
Yes, this is the normative database that we use in the harmonized qEEG, that, as I said, is a project that we did within the framework of Global GBC, Global Brain Consortium, and we collected databases from 14 groups working in 9 different countries, and they were around 1,600 subjects in their age range from 5 to 85 years old. It was more or less same age range that the Cuban Normative Database, the previous Cuban Normative Database, and that's why I say that we were able to compare the power of our old database with the new one, no? But besides this, also we incorporated the new features that the harmonized qEEG has. If no more questions, okay.